Okay, here we are discussing the homopolymer, and we're talking about homopolymers with regards to plastics. And there's homopolymers and copolymers. So to understand what each is, we'll just discuss the homopolymer. We'll have to look at it on a molecular level. So we'll take a look at this image right here that's in the document. And when we look at on a microscopic level, a molecular chain, it looks like a strand of spaghetti. And when you look at the backbone of that strand of spaghetti in polymers, they're carbon backbones. It's carbon based, it's organic. And if you zoom into those little carbon backbones, those look like little balls in this image, you can see a repeating unit that happens here. Carbon with two hydrogen and a carbon with one hydrogen and one chlorine. That occurs again and again and again. And when they repeat like that, that's called the repeating unit. So if you break it down to the basic repeating unit, single unit, that's called the mer, M-E-R. So like polymer, the repeating unit. So polymer in Latin means many units. And that's that. So poly means many and mer means units. So if we look at the base unit or the repeating unit, that's what we see here. So this is PVC, polyvinyl chlorides. So we see that the chlorine is sticking out on one of the carbons. So you have a carbon with a hydrogen on either side, and then a carbon with a hydrogen and a chlorine. Now this chlorine is very, very big relative to the hydrogens. So this chlorine sticks out. I mean, it's like a huge beach ball sticking out on one side of the chain. Now, if you look at the chain and you see a chlorine on one side of the chain and it's a huge beach ball, the next chlorine that's only two carbon atoms away, carbon molecules away, I should say, because it's so big, it can't reside on the same side. So because these beach balls are going to interfere with each other, this beach ball, this chlorine will get pushed to the other side. And because there's another chlorine nearby, it'll get pushed away. So they'll be like spaced, 1/3 of the diameter apart from each other. So that as these chlorines rotate around this molecule, they interfere with each other because they're so big. It's called steric hindrance, S-T-E-R-I-C, hindrance, and they're basically just smashed against each other because they're just so darn big. D is they kind of protect the backbone, these carbon backbone molecules. So it creates a chemical resistance for the actual carbon backbone. So other chemicals can attack it and dislodge it. And because chlorine has a negative charge, it repels many chemicals too. Now, on a different note, when heat is applied, like fire, extreme heat is applied, it will break the chlorine off of the backbone. It takes enough energy to break the chlorine off. And that chlorine will combine with hydrogen in the air, creating hydrochloric acid. And that is toxic. That is poisonous. So while this is an organic resin polymer, if you will, because it's carbon based, if it does catch fire, it creates a toxic fume that's really dangerous. So that'll explain why if you've ever heard of chlorine catches fire, PVC catches fire, it creates hydrochloric acid. You don't want to burn. You don't want to breathe in the fumes. It's very toxic. So that is the pretty much the definition of what a homopolymer is. It's the same repeating unit over and over and over. So homo is the same.